Okay, in this video we are going to discuss a problem on natural response of series RLC. Okay, in this case we will be finding the current. Okay, so there are three cases as we discussed in previous videos: underdamped, overdamped and critically damped. There are three different formulas for those. Okay, so we supposed to know those formulas also. So I'll just quickly show those formulas and come back to the problem. So this is one formula: I of t equal to e power minus alpha to b1 cos omega dt plus j b2 sin omega dt. So we have to remember this. This is for which case? Underdamped case. For critically damped, I of t equal to a2 plus a1t e power minus alpha t. This is for critically damped. And for overdamped, I of t equal to a1 e power s1t plus a2 e power s2t. This is the formula for overdamped. So identify the case. Okay, based on the case only the formulas to be considered. Okay, this is the one important thing you have to remember. There are three different formulas for finding the current. Okay, one is for overdamped case, second one is for critically damped case, and third one is for underdamped case. Okay, so now let us come to the problem. Okay, so find I of t in the circuit of figure below. Assume that the circuit has reached the steady state at t equal to 0 minus. So the time itself is given at what time the circuit reaches steady state. Okay, and then from the diagram I can conclude that at t equal to 0 the switch is getting opened. It means before that it was closed. Okay, so I can assume that for a long time the switch was closed. Okay, the switch was closed for the long time. For t less than 0 period the switch was closed. Okay, so suppose that the switch is closed and your inductor and capacitor are excited with a source for a long time. Okay, so inductor will act as a short circuit and capacitor will act as an open circuit. We all know it. Okay, inductor act as a short circuit and capacitor act as an open circuit. Okay, once it reaches steady state. When it reaches steady state, if the source is connected for a long time, it will automatically reaches the steady state. Okay, it automatically reaches the steady state. So we assume that for a long time it was connected at t less than 0. So at t equal to 0 switch is getting open. So I am going to consider a time just before the switch is open, which is t equal to 0 minus. Okay, I am going to consider the time t equal to 0 minus. So 0 minus is just before 0. Okay, at the time the switch was closed. Okay, so that is happening before 0. Okay, 0 minus is happening just before 0, but 0 minus and 0 are same for us. Okay, the same for us. The order of execution is different. So 0 minus is happening first and then 0. Okay, so at t equal to 0 minus the circuit reaches steady state. This capacitor will act as an open circuit. Okay, so I will be replacing this with open circuit. So if I am replacing this with open circuit, so my circuit will have like this. Okay, so but there is no connection between these two terminals, so there will be no current flowing through the resistor, so I can simply ignore the resistor. That is why we didn't draw the resistor here. Okay, this 3 ohm resistor is not drawn here because there is an open circuit, there is no path for the current to flow through the resistor, so I can ignore that. And then this 0.5 Henry is replaced with the short circuit. Okay, at steady state, as I already told, the inductor is acting as a short circuit. Okay, so it is acting as a short circuit. Okay, next. Okay, what is the time now? Time t is equal to 0 minus. So that is the current which is flowing through the inductor. Okay, if I am talking about current, I will deal with the inductor because the inductor current will not change instantaneously. If I am talking about voltage, initial voltage, I will deal with the capacitor. If I am talking about the initial current, I will be dealing with the inductor. Okay, So I need to find I of 0. I of 0 is the current which is flowing through 6 ohms. because 6 ohm is connected in series with the inductor. Okay, one word you have to remember, I told that the inductor will act as a short circuit. Okay, it doesn't mean that we are going to remove it from the circuit. The circuit, it is there, but it is acting as a short circuit. Okay, similarly the resistor, 3 ohm resistor and this capacitor also available in the circuit, but the capacitor will act as an open circuit at steady state. If it is acting as an open circuit, it is not going to allow the current to flow. Okay, so we are calling that as acting as open circuit. Okay, now I'll simply find what is the current I0. I0 equal to the total voltage by 4 plus 6, 10, just 1 ampere. So initial current is 1 ampere. What is the initial voltage? So initial voltage is the voltage across the capacitor. Okay, initial voltage is the voltage across the capacitor. Okay, so I am going to consider which is equal to the voltage across 6 ohms, because these two are okay. We are just considering that will be the voltage across this 6 ohms. Okay, so 6 I0. Okay, V of 0 minus equal to 6 I of 0 minus, which is equal to 6 plus, sorry, 6 times 1 will be 6 volt. Okay, so we got 6 volt. So give me a minute. Okay, I of 0 is the initial current through the inductor, which is 1 ampere. V of 0 minus is the initial voltage across the capacitor, which is 6 volt. Okay, for t greater than 0, how the circuit look like? For t greater than 0, the switch is opening. Okay, the switch is open. If this switch is opened, so I will be having only this part of the circuit. I will be having only this part of the circuit. If I redraw it, I will be having 3 ohm, 0.02 farad, 6 ohm and 0.5 Henry. All are connected in series. So I am going to rearrange this two. Okay, capacitor and resistor. So and I am going to add the 6 and 3, because I am considering all the 3 elements are in series. Okay, if you see this, you can understand. Okay, all the 3 elements are in series, so I am just adding 6 plus 3, I am going to get 9. So all the 3 elements are in series. Earlier there was 4 elements, so all the 4 elements were in series. So I added 3 and 6, I got 9 ohms. So R is 9, L is 0.5 and C is 0.02 farad. Okay, now find out what is alpha. Alpha equal to R by 2L, will get 9, and omega naught equal to 1 by root LC, which is 10. Okay, and I can calculate the roots. So S1 equal to minus alpha plus root of alpha square minus omega naught square. So that will be around minus 9 plus J 4.359, and S2 equal to minus alpha minus root of alpha square minus omega naught square. Okay, and we will get minus 9 minus J 4.359. Okay, so now it is in this form, minus alpha plus or minus J omega D. So what is omega D? Omega D is 4.359, 4.359, and alpha is equal to 9. Okay, so now here it is alpha less than omega naught. If alpha is less than omega naught, I can decide the response is underdamped. If the response is underdamped, I need to consider this particular formula for underdamped case: e power minus alpha t b1 cos omega dt plus b2 sin omega dt. We got what is omega d. Okay, just substitute all the values. E power minus 90 in the place of alpha we have 9, b1 cos 4.359t plus b2 cos b2 sin 4.359t. Now we need to find out what is b1 and b2. For that I need to consider the initial conditions. So I will substitute t equal to 0. Okay, if I substitute t equal to 0, e power 0 b1 cos 0 plus b2 sin 0. Okay, sin 0 is 0, cos 0 is 1. Okay, so I of 0 equal to e power 0 times b1, that is what we got. E power 0 is also 1, and I of 0 we already found out, which is 1. Okay, at the starting of the problem we found the initial current. I of 0 minus is equal to 1 ampere equal to I of 0. So I got b1 equal to 1, and then dI of 0 by dt. Okay, this dI of 0 by dt formula we have derived in lecture 1 RLC circuits in unit 4. Okay, so you can if you have any doubts in it, you can go through that. Otherwise you just remember this formula. Okay, this formula can be used directly here in this problem. dI of 0 by dt equal to minus 1 by L or I of 0 plus V of 0. So this is the formula, okay, we are supposed to use. Okay, so we know what is R, which is 9, I of 0 is 1, V of 0 is minus 6, so V of 0 is 6. Okay, here we are considering V of 0 equal to minus 6 because the polarity of the V in the figure is opposite to the general assumption. Okay, the polarity is just opposite to the general assumption, so we are using minus 6. Okay, we are using minus 6. Okay, so here we got 9 times 1 plus multiplied by minus 6 multiplied by minus 1 by 0.5, we got minus 6 ampere per second. Okay, this is dI of 0 by dt. Now where can I substitute this? So I have to take the first derivative of the equation which we got. Okay, this equation first derivative I need to take. It means I need to differentiate this one time. So dI of t by dt in dI by dt equal to this e power minus 90. If I differentiate, I will get minus 9 e power minus 90. I will keep this as it is, u dv plus v du. Okay, in that form. Okay, next case I will be keeping e power minus 90 as it is, and then I am going to differentiate this. b1 cos 4.359 t can be written as cos t will be written as sin t. Okay, so minus sin t, so minus b1 sin 4.359 t multiplied by 4.359, that is what we will get. Okay, and then b2 sin 4.359 t will be differentiated to b2. Okay, this will be sin t can be differentiated to cos t multiplied by 4.359. Okay, if I differentiate this, I will get 4.359. So I am going to take 4.359 as a common, so I have written here 4.359. Okay, at time t equal to 0, I substitute all the t as 0. So minus 9 e power 0, b1 cos 0 plus b2 sin 0 plus e power 0 minus b1 sin 0 plus b2 cos 0 multiplied by 4.359. So we will get dI of 0 by dt is minus 6 equal to minus 9 plus 4.359 b2. So b2 can be 0.6882. Now substitute b1 and b2 in that equation. I of t equal to e power minus t cos 4.359 t plus 0.6882 sin 4.359 t amperes. Okay, this is what the answer we got. If you have any doubts, kindly ping me in the comment window. Okay, next. This is another question. This you try it on your own. I'll show the whole thing in a video. Okay. So just if you want, you can write down. Okay, and solve it on your own. Okay. The circuit has reached a steady state at t equal to 0 minus. The circuit has reached a steady state. It means at a t equal to 0, the switch position is going to change. Okay, the switch position is going to change at t equal to 0. It will go to the position B. It means before that it will be in the position A for a long time. If it is in the position A for a long time, the inductor will act as a short circuit, so I can find out the current flowing through the inductor at steady state. Steady state time we are going to take it as t equal to 0 minus. So at t equal to 0 minus, it will be I of 0 minus equal to 5 amperes. V of 0 minus equal to 0 volt. Why V of 0 minus 0 volt? This part of the circuit is not connected to any source. The capacitor is available here. Okay, before time t equal to 0, there was no source connected, so there is no possibility of initial voltage. So V of 0 minus is 0 volt. Okay, for t greater than 0, how the circuit look like? We have a connection like this. This connection will be removed. So we have RLC. connected in series. We know R value, L value and C value, and just find what is alpha, what is omega naught by using the formula, and then find out S1, S2, okay, and which case it is, whether it is under damped or over damped or critically damped. Based on that, select the formula, substitute the values, and substitute t equal to 0, and take the derivative of this and find what is dA of 0 by dt. This is actually dA of 0 by dt. So dA of 0 by dt, okay, you have to find this too, and then take the derivative of this equation and substitute this value here and find out what is B1 and what is B2. You can simply pause the video and make a note of it, and if you have any doubts, you can ping me. Okay, thank you.